So this is going to be the first video of the study guide review. I'm just going to do page 1, and so let's jump right into the first problem. So in these problems, you're going to need to annotate it and make sure that you're answering the questions for each part of the problem. So a farmer is fencing in a rectangular white regions on his field, okay? Consider the field with a width, all right, so I'm going to mark width of 8x, all right, so this is width, and a height, all right, so height of 2x measured in feet. Each fenced in portion has a width of 10 feet as shown. All right, so that means this is 10 feet. This would also be 10 feet. There's another 10 feet right here and another 10 feet right here. So it says for part A, define an expression for the width of just the shaded region. So the whole width we know is 8x, but the shaded region, we would need to remove these little white fenced in parts. So there's 1, 2, 3, 4 of them that need to be removed, and each one of them is 10 feet across. So that's a total of 40 feet that needs to be removed to just get the shaded region. So the width would be the original 8x minus 40 feet. So then part B says to define a function a of x for the area. Well, one way to define area is equal to width, except I just spelled width wrong. Hold on a second. Let's try that again. Width times height. All right, spelling not my strong suit. Okay. So that would tell us that our area function, a of x, is equal to, well, our width is 8x minus 40, and our height for the shaded region is the 2x that was along this edge. That hasn't changed. Like, there's nothing we're subtracting from that. Okay? So this right here would be our function for the area of the shaded region. I'm also going to box up part A here, the 8x minus 40, so you know that was done as well. So for part C, it says, what is the maximum area that the shaded region can be if the width is 200 feet? Well, our width is this expression that we found earlier. So if I say that that 8x minus 40 is equal to 200 feet, that will let me solve for x. So let's go ahead and solve this. So I'm going to add 40 to both sides. So let's see, 8x is equal to 240. I'm going to divide both sides by 8, and I'm going to get x is equal to, I believe that's 30, but I'm going to grab a calculator just to make sure. Yep, it is 30. All right, now that x answer isn't the answer to the problem because that's just the x that goes in here, right, in these little expressions. So if I want to actually find the maximum area, I need to use this function that we figured out in the previous part. And everywhere I have an x, I'm going to replace it with the number 30. All right, so area for 30 is equal to 8 times 30 minus 40 times 2 times 30. So I'm going to put this part into my calculator. So 8 times 30 is 240. 240 minus 40 is just 200. And then 2 times 30, so this is going to be times 60. So let's see, 200 times 60 is equal to 12,000. And now we want to give it units. So everything in this problem was in feet, and area is going to be feet squared. All right. All right, so that's problem number 1 for this farmer with his fence. I'm going to slide on down to number 2. Number 2 is going to be similar. It says, Michelle is making a poster for the science fair. Posters come in different sizes and have side panels of width x inches. So here's my x inches here and here. The total width, all right, so this is width, across the bottom is 36 inches, and the height for the poster is 10x inches. Okay, and so this is height. Height, all right. Michelle will only put pictures on the gray shaded region in the middle. All right, define a function area. So area is equal to, I told you I can't spell apparently. Hold on. Yeah, there it goes. Area is equal to, I'm going to do height times width. And if you say width times height, that's the same thing as height times width. Order and multiplication does not matter. All right, so A of x is going to equal, our height is 10x inches. Okay, so 10x times, now we've got to figure out this width. But remember, we're only looking at the shaded region. So the whole width is 36, but I need to subtract off this little part on the edge that's x, and I need to subtract off this little part of the problem that's also x. So that would be 36 minus 2 x's. So 36 minus 2x. Okay, so that's going to be our area formula for the shaded region. So now for part B, what is the maximum area of the shaded region if the width of the shaded region is 30 inches? All right, so shaded region is 30 inches, and that's the width. So our width here was 36 minus 2x. So let's do 36 minus 2x is equal to 30. And now I want to solve this. So I'm going to subtract 36 from both sides. Be careful with your negatives, please. So negative 2x is equal to negative 6. Dividing both sides by negative 2, I'm going to get x is equal to 3. Again, that x value is not the answer. Like, you're not done, but we're now going to use this x in this area formula. So A of 3 is equal to 10 times 3 times 30, whoops, hold on. Try that again, 36 minus 2 times 3. Okay, let's break this up in pieces. 10 times 3 is 30. And then inside the parentheses, you've got to do multiplication first. So 2 times 3 is 6. So 36 minus 6 is just 30. So 30 times 30 is, I'm pretty sure it's 900. Yep, my calculator is clarifying that for me. So 900, and everything in this problem was in inches. Area is squared. So 900 inches squared for the shaded region. All right, so I'm going to go ahead and slide on down to problem number 3, and that'll be the last part for this particular video. All right, so let's see what we got. We have a function f of x, okay, and f of x is equal to x minus 2 times x plus 5. And our directions say to dilate f of x by 2x. Now, if you've not heard the term dilation before in mathematics, this is basically telling you to multiply. Okay, so we want to take the entire f of x function and multiply it, in this case, by 2x. Okay, now our new function that we're creating has a name, and in part A it tells us the name. We're going to write the dilation of f of x as h of x. Okay, so when we write this, we're going to say h of x is equal to, now I'm going to use my dilation factor here of 2x. So 2x times, now I'm just going to write out the parts of f of x. So x minus 2 and then x plus 5. Now in this problem, in no part in the directions does it say that it has to be written in standard form. So we're done. Okay, be lazy. You don't need to multiply this out. Okay, and then for part B, identify the zeros of the function. Well, the way we're going to identify the zeros is take each one of our factors. So we have 2x as a factor, we have x minus 2 as a factor, and x plus 5 as a factor. And we're going to set each one of these factors equal to 0. Now that we have these three little equations, solve them. All right, so we're going to divide by 2 in the first one. 0 divided by 2 is still 0. All right, so there's one of my zeros. I'm going to add it 2 in the next problem. So x is equal to 0 plus 2 is 2. Okay, and for the last one, I'm going to subtract 5. So x is equal to 0 minus 5 is negative 5. So right there are my 3 zeros. All right, so at this point, I'm going to go ahead and close this video up. I will make separate videos for the other pages of the study guide. If you have any questions or concerns, please send me a message in Canvas or directly email me.